Guys, so we are working on functions and function notation. So functions are where we have inputs and outputs. An input is like your domain value or your x value you put in, and the y value or the output or the f of x or the range value is what you get out. So just like in an ordered pair, when you have an x and y, get this to work, an x and a y, have functions where we have x and y. So this order pair 2, 4, you show that the 2 comes first because x, and that matches up with the axis, and the 4 matches y-axis. So to write this in function notation, we use f of x. Now f is just the name function. X is a placeholder for input. So we're going to say f of x equals y. Now we need to ask ourselves, what is the x and what is the y? I can clearly see the x is 2, the y is 4. So to me, I know I need to substitute 2 for x, and that's going to equal 4. So what that really means is for the specific function. Right now we know what the equation is. We just know it's a function. When you put 2 in, you're going to get out. That's what we know. So on this other problem that you guys have on your paper, you are given an equation. You are given a function notation. Given a function notation, I don't want to do that. G of x equals x squared minus 2. So gx equals x squared minus 2. If you know anything about specifics, you know that this is a quadratic function because it has a square in it. What we're going to do is figure out for these values in the table, x values, we could find any other ones, but just for those, we'll plug in the x value, plug in the input to get the output. So we're going to do g, because g is your function name, of the first one is negative 2. And we're going to substitute in x, so it's going to be negative 2 squared minus 2. Now you just do the math. Left side is just going to stay the same because it's saying for this function, what are we going to get plug in negative 2? We're not solving for anything, we're just evaluating. So you get g of negative 2, and that's going to equal negative 2 squared is 4, because inside parentheses minus 2. And do the math, we get g of negative 2 equal to, so I'm going to put that in the table, then I can take that order pair and apply. It's going to be negative 2 in the x and 2 in the y. And that point's slightly, let me fix it, and that's there. So what we do is we do this function evaluation, substitute in the input every time we need to get the answer. So I just got an order. You need to do the other one. So if you wanted to do 0, you do g of 0, x is 0, equals x squared. Well, x is 0, so we don't write x, we write 0, minus 2. So g of 0 is negative 2. Solving for g, we just want to know when we put 0 to this function, when we push this button on this vending machine, what are we getting out? And that's a negative. Now, if you do that, I'm just going to do this in my head. You know that negative 1 squared is positive 1. Positive 1 minus 2 is negative. So for the input of negative, we get a negative, or a negative 1. And that, since it's a quadratic function, it'll mirror itself. But let's say you didn't know that yet. When I put a 1 in, 1 squared is 1, minus 2 is negative. Some symmetry here. 2, positive 2 squared is 4. 4 minus 2 is 2. And look at that. We have a quadratic, a parabola, because you know that quadratic functions make tables which are U-shaped, and my order pairs are a little off. And that's not the right order, not the right point either. So let me fix that. It's going to be negative 1, negative 1, 1. We have 0, negative 2. The y-intercept graph crosses the y-axis. I got negative 1. I got 2, 2. Plot those. It's not enough to just plot your point. You need to sketch your parabola. So go through each point, and it continues. Make sure you show the arrow that it continues. So yeah, functional take pretty straightforward. It's helping you find order pairs, and you know inputs, you can find outputs. When you know outputs, you can find inputs. You're finding what you don't know. So just think about it as finding points. The last type of problem you have is you're not really given a table or support, but you're just evaluate functions. So to evaluations, you take the inputs and plug them in. This is just like what we just did, and I'm going to show you how to just set it up. So for example, we have f of x. The function name is f, and it could be whatever. So f of x, but I'm going to x open. I'm going to use blue to show you. I'm going to put in there, and then you see for x. For x, it could say for inputs, it could for domain values. You're going to take one of those numbers, -2. We're going to do all of them. Plug them into the function to get the output. You a set of order pairs. And remember, guys, it could look like a graph. It could look like a mapping. It could be just order pairs. It could be a table. You can get all different representations of doing functions. So to find what the y value will be, the output, the f of x, we're going to do f of -2. We're saying when this function is -2 as the input, what are we going to get out? We equation. It's going to be -4 instead of x. I substitute with parentheses a negative. I add 3 on both sides. So I'm going to go there. Actually, no, I'm not. That's sloppy. I'll go down. F of -2 is going to be, oh, sorry guys. F of -2 is equal to 4 times 2 is +8. +8 plus 11. So I know that f of negative is 11. And that means when the input is -2, the output is 11. I can rewrite that order pair. I can plot that on a graph. I can do whatever. If we're thinking about time, distance, money, whatever, you wouldn't really get in that situation. But like when the Cannon Man, when he was 2 seconds along, he was 30 feet in the air. It's a relationship between the input and output, and we remember that a function is when you have a relationship between the input and output, where each input only has one output. That's all I got for you.